guys, we're going to talk about systems of linear equations and what we can do to solve those. We'll spend, I guess, the majority of our time solving them with the calculator instead of doing it by hand. I don't see the benefit of doing it by hand when most of you are going to do it with the calculator anyway after show it to you. So that's what we're going to do. The three scenarios can happen with any system of equations, linear systems. That's on free. You can see what three scenarios things can happen with linear systems of equations. You could have one solution. That would be consistent and independent. Would be the mathy way of describing that. You could have infinitely many solutions. Many solutions. That would be consistent and dependent. So consistent, meaning it has answers. Independent, it only has one solution. Dependent, it has infinitely many solutions. And the third scenario is that there is no solution at all. And that would be inconsistent. No matter what size system of equations, if we've got a system of equations that has 2 variables or 3 variables or 75 variables, those three scenarios are what could happen with those. One of those situations is going to describe what's going on. So let's look at some systems of equations and how we solve those. X plus 4y, fix that eraser, equals 14, and 3x minus 2y equals 0. There's several ways to solve a system like this. One way would be with graphing. You could get those two equations in slope-intercept form, graph them, and see if they cross. If two equate the lines, if they cross, they got one solution. If they lie right on top of one another, at same slope, same y-intercept, then there are infinitely many solutions. If they don't cross at all, they're parallel lines, and parallel lines have no solution. You could graph them and solve them. That's probably not the best way, though, because what if they don't cross at a nice place, like, like -2, 5 is a good point. It's easy to find. But, 13 over 3 and 6 over 8 is probably not a good spot. It's harder to estimate that with a graph. So graphing is not a great way. Another way to solve would be substitution or elimination method, which works fine. You may have done that some in high school math. That's also a decent way. It's a better way than graphing, but it's not quite as easy as using the Gauss-Jordan, G-U-A-S-S, method, which uses a matrix. And this would be a 2 by 3 matrix. And you have the coefficient part of the matrix, which would be 1, 4, 3, -2. And then you have the augmented part of the matrix, which is what those equations are equal to. So 14 and 0. A lot of books will put like a little vertical line here. That doesn't necessarily have to be there. It won't be there on our calculator. I put it there just because your book tends to put it there. But it's not necessary to be there. And what we'll do is your calculator is going to do all the work for us, but it does these row operations to get this thing in what's called reduced row echelon form, ECH. form. And the big thing there is the first letters, RREF, because our calculator can do that. So what's going to happen when it puts it in reduced row echelon form is you're going to get ones and zeros in this pattern on the coefficient side. what this says is x and 0 y's, and then we'll get a number here. We're going to do this with the calculator in just a second. This says no x's, but 1 y is equal to this. So on your matrix, you got an x column, a y column, what it's equal to column. That's how that works. And each row is an equation. So on the calculator, to do that, you're going to go to the matrix menu. And in order to get there, you're going to press second and then the X inverse button, which is right below the math button. It says matrix right above it. And it'll take you to this menu. So second and then X to the -1 button. And then we're going to go over to edit. And I'm going to use matrix A. And we're going to change its size to a 2-row by 3-column matrix. And then we're going to enter in that matrix that we have, which was 1, 4, 14. And then the second row was 3, -2, and 0.
Just a reminder that the Lifeline Bloodmobile will be here till 6 p.m. So we have around 2 hours left. Make sure you give blood. Thank you.
All right. And yeah, they never do that. So it's going to freak me out a little bit too. So we've got it first row, second row in there. You make sure everything's in there. If you miss one of the elements in there, mess it up, it's going to mess up the whole problem. So don't screw that up. That's the same. So second, quit to go back to the regular calculator screen, and we want to use RREF. So second matrix, and then I'm going to go over to the math menu. So in that matrix menu, there's a math menu. If you'll press the up arrow key, it's the quickest way to get there. Or alpha B will also get you to RREF. That stands for reduced row echelon form. And you hit enter, and it asks, okay, what do you want to do that to? We want to use matrix A, that we put that in there. So second matrix, and then the first matrix A, and hit enter. And it cranks out this reduced row echelon form. 1x plus 0y equals 2. 0x plus 1y is equal to 3. So 2 and 3. So what that tells us is x equals 2, y equals 3. The ordered pair would be 2, 3. If you were to graph these two equations, they would cross at the ordered pair 2, 3. That's what that's telling us. Quite possibly the easiest way to solve that. You may be quick and very adverse at using substitution or elimination to solve, and that's fine. That's how I would normally do that. So I'm just as quick doing that as I am typing in a matrix, just because I've done it 8 gajillion times. So just takes practice. If it's a larger system, definitely easier to do Gauss-Jordan reduced row echelon form than it is to try to eliminate variables and things. Take, for example, if you've got 2x minus y plus z equal to 0, and then x plus z plus z minus 1 equal to 0, and then x plus 2y minus 8 equal to 0. This one is a little messed up, but it's got 3 variables in it, which makes it much more difficult to do. What you need to do, though, is get it set up so that it can be put into a matrix, and that would mean that you need to have x column, y column, z column, and then what it's equal to. So you need only x, things with variables on the left side, numbers on the right side. So these two equations down here need to change into x plus 2y equals 8. And this one would be x plus z equals 1. And this one would be 2x minus y plus z equals 0. So now we have a much more uniform style, the way it's looking. You got an x column, you got a y column, you got a z column. There's some stuff missing. And if it's missing, we're going to put what in the place of it? Zeros. If it's missing, it means it's not there, so it's zeros. So our matrix that we're going to enter into the calculator would be 2, -1, 1, 0, 1, 0, 1, 1, 1, 2, 0, 8. And again, your book tends to put that little vertical line there, but it's not necessary. So what size is that matrix? 3 by 4. 3 rows by 4 columns. So in my calculator, I'm going to go to the matrix menu, second, X inverse, go over to edit, and I'm just going to use matrix A again because it really doesn't matter which one. I've got 10 choices, but I'm just going to use A again. And I'm going to change that to a 3 by 4. Put that in there, 2, -1, 1, 0. Second row is 1, 0, 1, 1. And then 1, 2, 0, 8. And then use RREF for math. And then tell it which matrix to do that to. And there I get X is equal to 2, Y is equal to 3, Z is equal to -1. So get this matrix 1, 0, 0, 2, 0, 1, 0, negative, or +2, or +3, and then -1 was what Z was, right? So X equals 2, Y equals 3, Z equals -1. That's written usually as an ordered triple. So that would be X, Y, then Z in alphabetical order. Anytime the variables are different, just alphabetical order is the standard way. 2, 3, -1. So that'd be in three-dimensional space. You'd be talking about one point where 3 planes come together. So it'd be kind of like where the wall, 2 walls and the ceiling meet. That's that corner is that one point is where we're finding there. So there's with a couple of examples of one solution for a system of equations using RREF with the calculator. Let's look at one of the other scenarios. Maybe we have this system. 6x minus y minus z equals 4, -12x plus 2y plus 2z equals -8, 5x plus y minus z equals 3. And we want to solve that. So I'm just going to go straight to putting it into a matrix. And that's a 3 by 4 matrix again. And then I'm going to run RREF on that matrix and see what it gets me. Second matrix, I'm going to edit the 3 by 4 again. So I've already got one of those set up. And then just put in the numbers 6, -1, -1, 4, -12, 2, 2, -8, 5, 1, -1, 3. And here's a little shortcut. If you don't want to hit math, hit matrix and go to the math menu. If you've already used that matrix, I know you used A earlier, I could just press the up arrow until I get that command and then pull it down there, hit enter again. And it gives us decimal solutions there. I'm going to change that to fractions. So math, enter. And the biggest thing to look at here is the fact that that bottom row looks pretty suspicious. And then so scroll down here, we can see that that bottom row has all zeros on the bottom. And if that's what's happening, then what that tells us is this is infinitely many solutions. Now, maybe in your high school math class you stop there and said it's infinitely many solutions. There's nothing else to do. Well, that's not what we do. We have to write those solutions in a certain form. Okay. So if we wanted to write the solutions in the form of z, that would mean we want all of our answers to have z's in them. We've got two equations. We've got the equation x minus 2 over 11z equals 7 over 11. And then we've got an equation that says y minus 1 over 11z equals 2 over 11. If we're going to write our ordered triple in the form of z, that means z is in every solution. We're going to have an ordered triple with just z's in it. All I have to do is solve for the variable that I don't want. So I don't want z's, I don't want x's in there, so I'm just going to solve this for x. That's a pretty easy step. So that's going to be x is equal to 2 over 11z plus 7 over 11. 2 over 11z plus 7 over 11. That's what the x position would look like. The second equation says y minus 1 over 11z is equal to 2 over 11. I can get y by itself for that one by adding 1 over 11z. 1 over 11z plus 2 over 11. All of those, the ordered pairs, if I pick a number for z, I can get what x would look like and what y would look like. If I pick a different number for z, I get what the x value would look like and what the y value would look like. So I can get, it's got an infinite number of solutions, but they're a certain infinite set. And they look like this. So we'll tell you what variable to go by. Z is the most common one. That's why I did that one. So you take your equations out of the matrix. I got x minus 2 over 11z from that first row is equal to 7 over 11. I got that equation from the matrix after doing RREF. The second row, the y minus 1 over 11z is equal to 2 over 11. I got that from the matrix after the RREF work that I did. All right, so let's look at another problem. Let's say we had this system, x plus y plus z equals 6, 2x minus y minus z is equal to 3, and then x plus 2y plus 2z equals 0. Okay. I'm using 3 variable systems because they're more complex, a little harder to do than 2 variable systems. 2 variable systems, you'd only have one equation that you'd even have to work with on the infinite number of solutions here. So with a 3 variable system, let's put this into a matrix. 1, 1, 1, 6, 2, negative 1, negative 1, 3, 1, 2, 2, 0. And then we run RREF on that. And I'll use the calculator to do that. Second matrix A, so 3 by 4, 1, 1, 1, 6, 2, negative 1, negative 1, 3, 1, 2, 2, and 0. Okay. Again, I'm going to run RREF on that, so I'm just going to press up until I find that command. Hit enter, and then enter again. And the bottom row there tells the tale. That's what's going to tell us what's going on. That bottom row has all zeros and a 1. That says 0x plus 0y plus 0z is equal to 1. Does 0 ever equal 1? No. So since that bottom row has all zeros and then a number there, it doesn't necessarily have to be a 1 right here. It could be any other number, but 0 never equals another number. It always has to be 0 equal to 0. That says there's no solution. And that's our favorite one because that means there's no more work to do when there's no solution. But it doesn't happen very often. Doing RREF to solve. So if the quiz or the test next week says solve by substitution or elimination, you can use RREF. That's what I would suggest, because you're going to check them that way anyway, most likely, and get your solutions that way. That's what I would do. So you solve a system of equations. As long as it doesn't have exponents on the variables, we'll get to those in a little bit. Then use RREF with the matrix on the calculator to do that. Okay. All right. Let's in the same section. There are problems about using row operations, actually performing them by hand. Instead of, we're not asking you, as a math department at UT, we're not asking you to actually perform row operations to get it down to reduce row echelon form in a college algebra class. That's something we do in linear algebra, math 310. So we're taking a matrix. And we're asking you to change row 2 by doing 3 times row 1 plus row 2. That's how the row operation would be given to you. If they give you more than one row operation, you do them in order of the way they're given to you. You do the first one, get the answer to it, then use the new matrix as the starting point for the second row operation. So here we got one row operation that we're doing. So we're going to change row 2 is the only row that's changing. That's what this tells you, is that row 2 is the only guy changing. So when you get your answer, row 1 is still this. Row 2 changes by doing that operation. We say 3 times row 1, and then we add it to row 2. So 3 times 5 would be 15. 15 plus negative 3 would be 12. And then we're taking 3 times 2, which is 6, plus 1 would be 7. 3 times 13 is 39, plus negative 10 would be 29. And that is the answer to doing that row operation. The key is knowing, hey, I only change the row that it says it's equal to. Don't change the other rows. If it has more than one operation, do them in order. Just like set 3 separate problems. If there's 3 row operations, it's 3 separate problems. You just start at whatever answer you get for step 1, use that to do step 2. Get the answer to that, use that to do step 3. So you do them in order with the row operations. Not really strenuous work here in this chapter even. All right. So that's section 1 and 2. 12.4. We're going to add and subtract some matrices. Let's say matrix A is 3, 6, 5, negative 7, 2, 10. Matrix B is 1, negative 2, 11, 8, negative 5, 14. And matrix C is 6, negative 4, 2, and negative 1. Okay. In order to add and subtract matrices, they must be the same size. If they're not the same size, it's undefined. You can't do it. Adding and subtracting, if we're going to add matrix A plus matrix B, you add matching elements. Okay, meaning the same spot adds the same spot. So when we're adding matrix A plus matrix B, we're going to take, these are the same size. What A is a 3 by 2, B is a 3 by 2. That makes that a defined operation, means we can do it. So I would add 3 plus 1, and that would get me a matrix back that's the same size. 3 plus 1 is 4. And then I would add 6 plus negative 2. And that would be 4. And then I would add 5 and 11, which would be 16. And then I would add negative 7 and 8, which would be 1. 2 and negative 5 is negative 3. 10 and 14 is 24. And I've added those two matrices together. You can do that with the calculator as well. If you just enter those matrices in your calculator's matrix A plus and matrix B, and then tell it to add them the same way you would do RREF, but you don't have to hunt the RREF. You just do matrix A plus sign matrix B, and it will add them together and give you back a 3 by 2 matrix as an answer. If it asks you to subtract, guess what? You do the same thing. We're going to do B minus A. You got to do it in order. So 1 minus 3, negative 2. Negative 2 minus 6, negative 8. 11 minus 5, 8 minus negative 7. Negative 5 minus 2, 14 minus 10. I generally don't add and subtract using the calculator. It can be done, though. If you're not confident in what you're doing, use the calculator. It'll do it. I'm not, if you're going to be an engineer, maybe you want to discipline yourself and make sure you learn to do it without a calculator, because you won't have a graphic calculator on the fundamentals of engineering test. You'll have the engineering calculator that they allow, which doesn't have matrices on it. Sorry. Good luck. Like a scientific calculator. It's got a few other functions on it, but not much. It's just almost a regular little scientific calculator is all I think that they allow on it. Now, I know they don't allow the graphing calculators on there. If you were going to do matrix A plus matrix C, it's undefined. Why is it undefined? Matrix A is a 3 by 2. Matrix C is a 2 by 2. They're not the same size, so they can't be added or subtracted. So that's undefined. If you tried to do that in your calculator, it would tell you a dimension mismatch error on your graphing calculator. It'd tell you that you can't do it. So it's a kind of a foolproof thing there. Another operation is scalar multiplication. And I like to think about this as just being distributive property. It's not distributive property, but it is. That's how you think of it, is it works like distributive property. So if you had matrix A was 2, 6, negative 7, 8, 5, 3. Doesn't matter what size you're dealing with there, and you did negative 3A. That just means take negative 3 and multiply it to everything on the inside of that. Which is why I think of it as distributed property. You're multiplying every element on the inside by negative 3. So that'd be negative 6, negative 18, 21, negative 24, negative 15, negative 9. And it ends up being that. That's scalar multiplication. It doesn't, if it's just simple scalar multiplication, I usually don't do it with the calculator. It can be done with the calculator. You just put the matrix in, say negative 3, matrix A, and it will crank out a matrix that's been multiplied by negative 3 all the way through it. Okay. Now, this is where I will sometimes use a calculator. If I had two matrices, let's say we had three, the same two from up top. Let's just use those two, A and B from up here. I'm just going to copy and paste those. And we're going to use those to do a combination of scalar multiplication and adding and subtracting. Matrix A and B there. If I ask you to do, example E, 2A minus 4B, you could do it by hand. You could say, okay, 2 times 3 is 6 minus 4 times 1. So 6 minus 4 is 2. You can do it by hand. I tend to, when they're asking me to do something like this, just to keep myself from making a lot of sign mistakes, is just go ahead and put them in the calculator as matrix A and B. And that was a 3 by 2, 3, 6, 5, negative 7, 2, 10, and then second quit. And I'm going to go to matrix B, make it a 3 by 2. We got 1, negative 2, 11, 8, whoa, 11, 8, negative 5, and 14. And then I would just on the regular calculator screen say 2, then go grab matrix A, minus 4, go grab matrix B. And it cranks out a matrix with that solution set. So I copy and paste that. Yikes. Yeah, it's quiet. There we go. Oops. So that would be what my matrix ends up being there. Right there's my solution. You can do it by hand. You can do it with the calculator. I don't care which way you do it. Just be able to do scalar multiplication combined with addition or subtraction. Then I would subtract. Yeah, that's exactly what. If I did it by hand, that's how I would do it. Yeah, just each element. I'd actually do that one element at a time. I do 2 times 3 minus 4 times 4. So 6 minus 4 would be 2. And then I do 2 times 5, 10, minus 44, negative 34. And I do that throughout the whole rest of it to get there. Is what I would do if I was doing it by hand. All right. Okay, let's look at multiplying matrices. Multiplying matrices is a little bit different than adding and subtracting. You actually don't always want them to be the same size. You can't have them be the same size sometimes when you're multiplying matrices. You look at the dimensions, and it's always row by column. And then you're multiplying times another matrix, and its dimensions are done the same way. Okay? These two have to match. If those don't match, then you can't multiply. So like you could have a 2 by 3 times a 3 by 4. Since that matches, that means you can multiply them together. If they don't match, you can't multiply them together. Those numbers in the middle for dimensions don't match, then you can't multiply them together. Since they do match, then the answer is going to be a 2 by 4. That comes from the outsides. So that can tell you, what size of an answer you should get. And multiplying matrices can be done by hand. It's not something that is really easy to do by hand because it piles up in number of operations really fast. Because if you're multiplying, let's say matrix A is 2, 4, negative 1, 5, 8, 0. So a 2 by 3. And matrix B is a 3 by 4. 2, 5, 1, 4. Let's brace that out. Looks like 14. and then 4, 8, 0, 6, -3, 1, -2, -1. Just to get the first element in the answer. When you did example F, A times B, just to get the first element in the answer, you've got to say 2 times 2 plus 4 times 4 plus -1 times -3. So that's 3 multiplications and 2 other operations. So that just for the first spot in the 2 by 4 answer, you've already done 5 operations. And then to get the next spot, it's another 5 operations. And then to get the next spot, it's another 5 operations. And the next spot's another 5 operations. So it piles up really fast in the number of operations. And the more operations there are, what are the chances of you getting one of them wrong? They're higher. Just because it's human nature to make a mistake. It's going to happen. Okay, so what you want to do is you want to multiply those together in the calculator. So we're going to enter those 2 matrices into our calculator. So I'll freeze that so you can just look at them. And then I'll enter them into my calculator. So second matrix. I'm going to edit. I'm going to go matrix A was a 2 by 3. And 2, 4, -1, 5, 8, 0. And then go into matrix B and make it a 3 by 4. Two, 5, 1, 4, 4, 8, 0, 6, -3, 1, -2, -1. Oops. Made a mistake there, so let me go back and fix that. All right, so I've entered those 2 in to my calculator, and I'm going to tell it to multiply matrix A times matrix B. And I don't think you even have to put the multiplication symbol in there. It'd still do it. And you end up with this 2 by 4 matrix as a solution to that. That would be the solution to that. Again, do it by hand. I don't recommend doing it by hand. I just don't think it's going to benefit you in a Math 140 class, where it probably would in a higher level math class, because you're going to do some things that are not straight just numbers in a higher level math class. So we're doing just numbers here. All right. Finding the inverse of a matrix. That's the next thing in this section. Inverse matrix. Again, this is something we're going to do on the calculator. We're asked to find the inverse of a matrix. Let's say matrix A is 1, 1, 0, -1, 3, 4, 0, 4, 3. A inverse is finding the inverse of that matrix. I'll put it on G. To find the inverse of that matrix, you're just going to go to your calculator and put that matrix in there. 3 by 3. One thing that might be handy knowledge is the fact that you can only invert square matrices. Had to be the same number of rows, same number of columns. If it's not a square matrix, you can't find the inverse of it. There's some reasons for that we need not go into for this course, but matrix linear algebra is one of my favorite courses, so I like it. It's fun. Not because it was fun on the calculator. It's not very much fun on the calculator. It's a lot more fun when you get into the theory of it. But so we've got that 3 by 3 matrix in there. It's matrix A. So I'm going to go grab that matrix, And then I'm going to use the inverse button on my calculator, which is right there underneath the math button. Don't hit second, just hit inverse. And it'll crank out the inverse of that matrix. And I want to change that over to fractions. So math, enter. And that would be the inverse matrix. So I'm going to copy that. Go down here. There's the inverse of that matrix. Inverse matrices can be used to do some interesting things in solving systems. We're just asked to find the inverse here, so we're not going to use them to do a whole lot with that. All right, so let's look at something that's a little more algebra involvement, and that would be the next section that we're going to cover, 12.6, nonlinear systems. A little bit more difficult, but a little less calculator, a little more brain. Nonlinear systems matrix algebra doesn't work real great when you get out of straight lines and we get out of flat planes. Matrix algebra doesn't work too wonderfully. Calculus works better on curved surfaces. When you talk about, I don't know if anybody went to see that movie, Hidden Figures. They do a lot of stuff with calculus in that movie. They don't do so much with matrices in there. A lot of calculations using calculus because they're dealing with the curved surface of the Earth. The spinning of the Earth creates a curved plane that you got to cross over to get into the outer space, the kind of realm of things. But so matrices are not really helpful when you have a curve going on. So you might have a system that may have a straight line in it, like 3x minus y equals -2. That's a straight line. But the other equation might not be straight, i.e. this one. You've got a quadratic. It's got x squared in it. So what we're dealing with here is where does the line intersect with a parabola? Okay, that's what we're really finding. So there's a couple of different ways to do that. One way would be algebraically, and that's the way that I tend to try to do these. So to do that algebraically, what you could do is solve one of your equations for a single variable and use substitution type method for that. I think it's easiest just to get this one to have y by itself. And if I do that, I get -y is equal to -2x squared. I could divide by -1 to get y is equal to 2x squared. Then I can take that and replace y in the first problem with 2x squared. So that's 3x minus 2x squared is equal to -2. And now that problem only has x's in it. It's got an x squared in there, but it's only got x's in it. And that's easier to solve than something that has two variables in it, right? So I'm going to try to solve that using things that I already know about quadratics. I know I can get it equal to 0 and have 2x squared minus 3x minus 2. And then I could factor that. -4 and 1, so that'd be 2x squared minus 4x plus 1x minus 2. And I could group that. 2x, x minus 2, plus 1, x minus 2. So my factors would be 2x minus 1 and x minus 2. I could have done quadratic formula there. X equals -b plus minus radical b squared minus 1. 4ac divided by 2a. I could have done that as well on the in red there, 0 equals 2x squared minus 3x minus 2. I could have done that and gotten the same two answers that I'm going to get here by factoring. 2x minus 1 equals 0, so that'd be x is equal to 1/2. And then x minus 2 equals 0 would be x equals 2. That gets me two x answers. I need ordered pairs. I need where's that crossing, the parabola and the line crossing each other. So I need to get the y values to go with it. I've got a nice equation right there in purple that says y equals something. So I can just plug these x's into that and get the y values. So if I plugged in 1/2, 2 times 1/2 squared, that'd be 2 times 1/4, which is 1/2. And then if I plug in 2, that's going to be y equals 8. 2 squared is 4. 4 times 2 is 8. So I get these ordered pairs: 1/2, 1/2, and 2, 8. And that's where those two would cross. Okay. All right, not too difficult on that one, I don't think. Substitution method of getting an answer. Let's look at a different method that can sometimes make it easier. Let's say we had x squared plus y squared is equal to 13, and then x squared minus y squared is equal to 7. You don't have to know this to do these. It's nice to know if you have had the math to remember. This is the equation of a circle, and this is the equation of hyperbola. I don't know if that rings a bell with anybody that's had conic sections in advanced algebra or something in high school. But you don't have to know that to solve these. You can still solve them without doing that. Because look at the y squareds. One's positive, one's negative. So if I added these two equations together, what's going to happen to the y squareds? They'll cancel each other out. That's elimination method of solving. X squared plus x squared would be 2x squared. 13 plus 7 would be 20. And I could subtract or divide by 2, and that'd be x squared is equal to 10. And then I take the square root. X equals plus or minus the square root of 10. And those are my x values. And I could get the y values by just taking that and those answers and plugging them into one of the equations. I'm going to go back to the top one. Doesn't matter which one. I'm just going to pick that one because it's got all positives. I don't have to deal with the negative sign. So if I plug in the square root of 10 in for x, when you square the square root of 10, what happens? It cancels out, right? That's 10. And then I could take the 10, subtract it over here to the 13, get y squared is equal to, that's a 10 that I'm subtracting, equal to 3. And then I take the square root plus or minus the square root of 3. So I get two ordered pairs from that one x value. When the square root of 10 is the x value, I get the positive square root of 3. And then I get square root of 10, negative square root of 3. I got to do some more work because I got to plug in the negative square root of 10. Same thing's going to happen here. I get 10 plus y squared is equal to 13. Subtract 10, I get y squared is equal to 3 again. And there's the square root. So y is equal to plus or minus the square root of 3. So at negative square root of 10, I get plus and minus the square root of 3. So I get 4 answers on this one. They won't always be the same number. That's why I showed the step of actually solving them. It won't always be the same numbers. It's nice when it is because it kind of seems to make more sense, but it won't always be the same numbers. But elimination method a lot of times is a quick and easy way to get rid of one of the variables. Substitution is always a good option. One of the teachers at my high school, he's a big substitution guy. He tries to use substitution for everything because he's pretty good at it. I'm better at elimination than I am substitution, just because I prefer that method because I do it more, and not necessarily that it works better. All right, So systems of nonlinear equations. That's kind of what I want you to do. Either substitution or elimination method. That's what you're going to see is the best way to solve those. Let's look at the next section. 12.7. It's related because I'm going to swap this over to graph paper and we're going to do inequalities. Darken those lines a little bit. So systems of inequalities. So example A, you might have y is greater than 3x minus 7, and then the second equation be y is less than or equal to negative 1/2 x plus 5, something like that. And you're asked to graph that system of equations. Okay? Not too often we're asked to graph anything by hand. Multiple choice type quiz situation or answer on the test, it's going to have the graph drawn. You got to pick the one that matches it. So I always thought that the easiest way to do that was to just actually graph it myself and then see which picture looked like the one I drew, instead of trying to inspect the ones that they had already drawn. Because I inevitably would always pick the wrong one if I didn't draw it myself. If I drew it myself, I was usually right, just because I would catch mistakes that I would make otherwise. So I'm going to graph the first one. I'm going to graph it with a red pen. -7 is the y-intercept. 1, 2, 3, 4, 5, 6, 7. I did go to the right spot. And then up 3/1. It's just a greater than symbol, so that means it's a dotted line. That a lot of times was the difference in the right answer and the wrong answer. Was one was a dotted line, one was a solid line. So you got to be careful of that. And then the shading that happens with inequalities. We got to decide which side of that to shade. Some people teach that if it's greater than, you always shade above it. But what's above that? It looks like it's got left and right, not up or down. So I always struggled with doing that. I'd say to that side would be greater than. But the best way, and the way that I teach it, is to pick a test point. Pick a point on one side. So I'm going to pick 0, 0 and say, is 0 greater than 3 times 0 minus 7? Is 0 bigger than -7? Yes. So that means I'm going to shade towards 0, 0. So I would shade this side of that line, because it was true. If it were false, I'd shade the other side. Okay. Now I'm going to graph the second equation or second inequality.
It's always the opposite side that it points to.
Always the true side. So wherever your test point is, if it's true, shade the test point. If it's false, shade the other side. So whatever your test point is, you pick it on one side of the line. If it's true, shade where that point was. If it's false, when you plug it in, shade the other direction. It's always shading the true side. It's always true. If you picked 1, 1, it's still on that side. If I picked that point, which is 1, 2, 3, 4, 5, 6, 7, hold on, 1, 2, 3, 6, 1. If I pick that point, is 1 greater than 3 times 6 minus 7? 1 greater than 18 minus 7 is 11. Is 1 bigger than 11? No, that's false. So I'll shade the other side of that line. So no matter where you pick your ordered pair at, if it's true, shade the place that ordered pair is on. If it's false, shade the other side. Mm-hmm. Yeah, if it's true, you shade that side. If it's false, shade the other side. All right, so I'm going to graph the other one. We'll do purple. Y-intercept 5, slope of -1/2, down 1/2, down 1/2, down 1/2. And then it's a solid line because it has the equal to mark. It's important. And then shading, I can check 0, 0 on this one because I'm checking it in respect to the purple line. It doesn't matter what it's done before. So 0 less than Negative 1/2 times 0 plus 5. Is 0 less than 5? Less than or equal to 5? Yeah, that's true. So I'm going to shade below that. I'm going to shade the underside of that line. And then the overlap is where the answer is at. If you're shading all in one color, be the darker spot. Mine's the overlap of the blue and the green, which ends up being just the green part there. Technically, there's some more of this line up here that's going, and it's got blue shading up here. Technically, is what's that makes it a little more clear that the highlighter color is the answer. That really does not match the color of mine. Mine's green. That's highlighter yellow. I don't. That's a nice projector. It's a lot better than the one I got at school. So. All right. Let's look at a nonlinear one. Example B. Y is greater than or equal to x squared minus 4. And then x plus y is less than or equal to 2. I like it when they do both equal to marks because that means I don't have to think about the lines. They're both solid lines. That makes it easier. So I'm going to graph these. I know I got to go to the negative 4. Make it that way. That'll work. So the parabola there has a y-intercept of negative 4. And then, plug in a 1. 1 squared is 1 minus 4 is 3. And that means the other side the same way. Plug in a 2. 2 squared is 4. 4 minus 4 is 0. The other side the same way. So there's the graph of the parabola. Just by picking some ordered pairs for x, getting that shape. And then I need to decide how about shading that. Do I shade the inside of the parabola or the outside of the parabola? So inside, in between, like the inside of my hands there, or where my fingers are on the outside. Okay, so I'd pick an ordered pair. I'm gonna pick the easy one. 0, 0. Is 0 greater than or equal to 0 squared minus 4? Is 0 bigger than negative 4? Yes. So that means I'm gonna shade the inside of that parabola. That shading continues up from there. Okay, then I'm gonna graph this one. I'm gonna get x over here on the other side, so it's y is less than or equal to negative x plus 2. So it has a y-intercept of 2, a slope of negative 1, and it's a solid line, so it looks like that. And then shading, I'm going to check 0, 0 again. Is 0 less than or equal to 2? Yes, that's true. So that means I'm going to shade down. And again, whoops, move that up. The shading where it overlaps is the solution area. So the highlighter area, highlighter yellow area again there. Or green area on my screen. So. You could use, like, some businesses use inequalities, like if they've got a curve that fits like their production, flow, of course, over a number of hours, they might be able to look at 2 different products that they're making and see where the overlap occurs with those. And I would say maybe it's some sort of investment principle. I don't teach business classes, but I would assume that there's some sort of business application of this for investments and where's the best place to put your money, or where are you going to be making a profit if you've got this curve fits a profit margin and this other curve is your expenses based on the variables that you have for those. Where do they overlap? Where do I need to make sure I keep that variable under control at? So there's some application there. Everyday life, I'm gonna be honest, you're not going to use it, I promise. All right. The last section of the semester is section 12A. And this one is more of an application type section. I'm not going to make it too hard on you. It's linear programming. is what it's called. It's just inequalities. Is all it means. It's fancy work, fancy talk, makes you scare people, because that's what math teachers do, scare people for using inequalities. Okay, so what'll happen is you'll have this objective function or an objective equation, and it means something. The context of it may come from a word problem. They'll say this company has a profit equation of this. That's their objective, is to make profit, right? So they would have a profit function that, that I is equal to 0.2 or 0.02x plus 0.03y. They've got some sort of equation, objective function or equation that they're using. And then they say, okay, there's these restrictions on what we're doing, where x is greater than or equal to 0, y is greater than or equal to 0. We've got this other inequality that applies to this problem. It's x plus y is less than or equal to 25. And then x is also greater than 15. And then y is also less than 5. And what happens is you get these inequalities and you're asked to graph them. So you would just graph these on a coordinate plane. So I'm just going to draw a quick coordinate plane, and I'm going to sketch what the graph would look like so that we don't have to, I'm not going to waste your time. You can graph linear inequalities. Yep. Well, by themselves, graph them just like we did the last two examples. Same idea. What your main goal, though, is to do is when you graph these, you've got these certain things happening. So this x is greater than or equal to 15. That'd probably be this line right here. And then you'd have the y is less than 5. That'd probably be that line. And then the x is x plus y is less than equal to 25. If you graph that, it'd be something like that line maybe. And then you'd have, what would happen is you create this polygon that's got all the shading in it. You'd shade all those, and there'd be one place where they're overlapping. It's this polygon shape there. And the key thing is the corners. That corner would be at 20, 5. That corner right there would be at 25, 0. This corner here would be at 15, 0. You would find these, or they would be given to you. A lot of the time, you're going to get this graph already drawn for you, and they're going to give you an objective function, and all you've got to do is get those ordered pairs and use them. So it will make it all the inequalities over there will make that polygon if you graphed them all and shaded them. They'd make that polygon shape there. Not gonna, you won't have nonlinear equations in this. It will always be straight lines. Okay. And then the idea is to take those ordered pairs and plug them into the objective equation and work them out. So you've got the ordered pair 15, 5. You would plug it in. And get an answer. So what 0.02 times 1.5 plus 0.03 times 5. Get an answer. 0.45. And then you would use the next ordered pair. If we went to 15, 0, let's use that one. Use the 15s up. 0.02 times 15 plus 0.03 times 0 would be 0.3. And then do the next ordered pair. Let's do 25. You'd plug that into the objective function or objective equation, whatever they're calling it on that problem, and work it out. 2/10 of 20 be 0.4, 3/10 of 5, 0.55. And then the last ordered pair we've got is 25, 0. 0.02 times 25 plus 0.03 times 0. And that's equal to 0.5. And then they would ask you for a maximum or minimum. The maximum would be 0.55 at 25. The minimum would be the 0.3 at 15, 0. They're going to ask you for one of those, not necessarily both of them. Ask you for a maximum or a minimum. And they would have some sort of context that this is the profit margin or this is a loss on a product or gains on a product or some sort of application of that. They're going to give you some sort of context to that for the maximum number of widgets to be built in such and such days, something like that. I don't know what it'll be. Be some different stuff there. But linear programming is the name of the game. You can get the inequalities, you get some sort of context with the objective equation. You just plug in the corners of your polygon on into that objective equation where those vertices are, those corners. Get the ordered pairs, plug them in. Maximum's the biggest answer, minimum's the smallest answer. Really, really simple stuff. Okay, bless you. All right. So tomorrow, or for this week, you will have a chapter 12. Basically, it's a chapter 12 practice test that'll be online as your Canvas quiz. And you'll get multiple chances on doing that, just like we have the whole semester. Monday of next week, we'll come in 4 o'clock. We'll have our chapter 12 test, which will be a different version of that Canvas quiz. You just won't have your notes or, and all that stuff handy like you do when you're doing it on Canvas. Okay, so it'll be the exam. Then next week, the May the 1st, is your final exam. Start at 4 o'clock. You'll have till 6 o'clock. 50 questions, multiple choice. It will look like this one. Make sure you get one of these before you leave. This has the answer key on the back. Feel free to work your way through that. You're going to have it for 2 weeks. Make sure you're ready for chapter 12. Work on this sum as you go. And you got 2 weeks to get ready for that final. But May the 1st is when your final is. It's multiple choice, 50 questions, just like that is. Just different kind of problems. It may not necessarily be exactly like that in the same order or anything. It probably will be different problems, but the same material will be covered there. So that'll get you a good idea of what the final is going to be like. My suggestion for you on that is to take that the first time. Don't look at the answers. Just take it. Give yourself 2 hours and take the test. Then grade it. See how you did. Go back and figure out what I do wrong on the ones I missed. And then take it again. I will post a PDF of that out on Canvas, a link to our lecture tonight too for all those folks that decided that my class was not as important what they're doing tonight. So tell them that it's on Canvas, and that'll be on Canvas as well, and your quiz will be on there before the end of the night. Okay? Appreciate you guys. Last night of lecture. Celebrate.